Hello viewers, welcome to this video. I'm Venkat and this is Just Me, an open source channel. Right, I'm sorry, I've got a typo here, Kubernetes. Okay, so don't mind. In this video, I'm going to talk about TLS encryption for your web application running in Kubernetes cluster. So one of the viewer asked me in comments that he was having problem with creating the certificates. So I tried it myself and it worked. So I thought of making it a video and sharing it with you all. Um, so, okay, so we're going to be using Let's Encrypt, which is a free certificate authority. You can get certificates for your web application from Let's Encrypt. So we're going to see how we can deploy Let's Encrypt in our Kubernetes cluster. So for this, let me show you my notes. That will make more sense. Okay, so the cluster wise, I've got master and two worker nodes. The cluster is going to be the same for all my videos. So 3 node cluster, 1 master node, 2 worker nodes, and I've got a HAProxy. So all of them are LXC containers. They're all CentOS 7 with 2 gig of RAM and 2 CPU. These are all running on my host machine, which is a Dell laptop with 16 gig memory and 8 CPU. I'm running Fedora 30 GNOME and the kernel version is 5.0.13. So that's my setup for this video, and I'll be using Helm to deploy the Let's Encrypt cert-manager, and we need the Nginx Ingress Controller. So basically what we'll be doing in this video, what I'm going to show you in this video is the first step is deploying your K8s cluster using LXC containers. And then we're going to install Helm and Tiller in your cluster. And then we're going to deploy the Nginx Ingress Controller. And then we proceed to configuring the HAProxy load balancer. And then we're going to install cert-manager via Helm Repo. So we'll be adding the JetStack Helm Repo, Helm Repo add, and then the JetStack channel or repo. And from that repo, we will be installing the cert-manager. So that will deploy a number of resources in your Kubernetes cluster. And then we deploy something called cluster issuer. So that's a custom resource definition, CRD. It's just a basic manifest, like if you create a deployment or a service using manifest. So those are all core resources available in Kubernetes. And we can also have our custom resource in Kubernetes. So when you deploy, when you install the cert-manager application, it will create a number of custom resource definitions, and one of them is cluster issuer. And the purpose of this one is whenever you deploy a web application and create an ingress resource, you specify the certificate authority. So the certificates will be generated by the certificate authority. So basically, this resource tells who is the certificate authority and where to find it. So those will be the setup. And then for testing, what we'll be doing is we'll deploy a sample Nginx application, and then we expose it using a service. That's a cluster IP service. It's not going to be a node port or load balancer type. It's just a cluster IP internal to the cluster. And then we will be creating an ingress resource. And then we do a DNS update. So when I say DNS update, as I'm running it on my local workstation, I'll be updating my etc host file to add an IP address to the domain for the Nginx web application. So I'll show you. It will make a good sense when I show you the demo. And then finally, we do the testing, which means we'll go to the browser and go to https://nginx.example.com and verify the certificate, who issued the certificate, and what's the validity of the certificate, and a bit of testing there. So let's encrypt TLS certificates, and this is my setup. Okay, so I've already done the first 2 steps. So I've got the K8s cluster using LXC containers, and I've installed Helm on my host machine and the Tiller component on the cluster. So here, if I do kubectl get nodes, I've got 3 nodes, kubectl get pods minus n kube system. You will see the tiller component deployed and it's running. If I do helm list, nothing, helm repo list. So I've got just the stable repository that gets added when you initialize the helm. Okay, so the first 2 steps, actually the third one as well, the Nginx Ingress Controller. I've done a video on all of these. If you want to have a look, head to YouTube. And if you want to know more about the LXC containers, search for Getting Started with LXC. So the first video here, Getting Started with LXC containers, will give you a good understanding how we can install LXC, LXT, and how to start the containers basically, and so on. So that's the first requirement. And then if you want to follow along exactly as in this video, basically I've done the cluster using the LXC containers. So if you want to know how to deploy a Kubernetes cluster entirely using LXC containers, you can search for Kubernetes LXC, and the first video here, deploying Kubernetes cluster using LXC containers. So you can refer to that video. And then Helm and Tiller. So that's a very simple topic, getting started with Helm. So that video here, Cube 24, getting started with Helm in Kubernetes cluster. And finally, Nginx Ingress in Kubernetes. So that video here, Nginx Ingress in K8 is bare metal. So these are not mandatory, but if you want to go through it, if you want to know more about it, and if you want to follow along my video, these 4 videos would make sense if you want to understand everything. But if you've got a cluster already running with Helm installed, then you can follow with me. So it doesn't make any difference how you run, whether it's LXC containers, virtual machines, or physical servers. As long as you've got a K8s cluster and Helm installed, you can continue watching this video. Okay, right. So now we'll go to the third step, Nginx Ingress Controller. So we're gonna deploy an Nginx Ingress Controller. Like I said, Nginx Ingress in K8 is bare metal. I've covered everything in this video, so I'm going to go through very quickly. I'm not going to explain each and every step. What I'm going to do is I'm going to go to GitHub Nginx Ingress. So that GitHub, and I'm going to clone that repository. Git clone Kubernetes Ingress. Okay, the repository has been cloned now. cd to Kubernetes Ingress, cd to deployments, kubectl create -f, common namespace and service account. Namespace and service account. So we've created a namespace and a service account. Kubectl create -f, default server secret, kubectl create -f, nginx config, kubectl create -f rback.yaml, and finally kubectl create -f daemon set nginx ingress. That's created, and if I take a look at the Nginx Ingress namespace, get all, and you can see the containers are getting created. So these are the Nginx controllers for each of my worker nodes, kworker1 and kworker2, and deployed as daemon set. Container is getting created. Okay, so they're all running now. Right. We've done the third step. Now we are going to configure the HAProxy load balancer. Right. If I do LXC list, so I've got these LXC containers, kmaster, kworker1, kworker2, and the HAProxy. So let me log into the HAProxy. LXC exec HAProxy bash. So I'm inside the HAProxy load balancer machine. I'm going to install HAProxy and NetTools. So NetTools package, if you install that, it will give you a command netstat. Using netstat, you can see what process are listening and on what ports they are listening. So basically, I want to know, once I configure HAProxy, I need to know whether it's enabled, it's running or not. So cannot find a valid base URL. Okay, there must be some problem with. Okay, I think it's working out this time. Okay, HAProxy is installed. Now let's configure HAProxy. Vi etc HAProxy HAProxy.cfg. So I'm going to leave all the global configurations as it is, and then the defaults configuration as it is, and I'm going to delete everything below the defaults configuration. Okay, so now I'm going to install. Sorry, I'm going to clone my Kubernetes repository. So I've got the HAProxy configuration stored in my GitHub repo. Git clone https github.com just me and open source Kubernetes. I'll put the link in the description if you want to download it. cd to Kubernetes, cd to YAMLs, cd to certmanager demo. HAProxy configuration, let's take a look. HAProxy.cfg. Okay, so that's the thing I want to copy. Copy and paste. Okay. So basically, I'm creating a front end. So the HAProxy service will be listening on port 443 for HTTPS. And the default backend is HTTP back, which is this one. And I've got the balance set to round robin. So each request will go to the other servers, one of the servers. So first request goes to first server, second request goes to second, third request goes to first. So it's kind of round robin fashion. There is also active passive, I think active standby or something. So the request goes to one backend server until it fails, and then it goes to, if the health check fails, it sends the request to the other server. So unlike that, so this configuration is round robin. So we use both the servers. Mode is TCP. That's important. Don't set mode as HTTP, or don't leave that option. You have to set mode as TCP. Because we are going to have the certificates installed on our worker nodes, not on the HAProxy. So if you don't give this option, and when you try to access the load balancer on port 443, it will expect a certificate on the load balancer, but we are not going to install certificates on the load balancer. The cert manager that we are going to deploy is going to automatically create certificates on the worker nodes. So this configuration mode is TCP. It's just going to just simple SSL pass through, which means any request coming on to port 443 will be forwarded to the backend servers, the two worker nodes. So no certificate validation is done on the load balancer. Okay, so bind 443 default backend round robin. Okay, now we need to copy the IP address of the worker nodes. kubectl get nodes -o wide. So k workers one IP address is this one. Copy and paste it here. And k worker 2 IP address is this one. Copy and paste. Save. Systemctl enable HAProxy, and then we can do systemctl start HAProxy, or we can do both in a single command. If you do systemctl enable ---- now HAProxy, so that will enable the service as well as start the service. Systemctl status HAProxy. HAProxy is running, and if I do netstat -nlcp, the load balancer is now listening on port 443. That's it. I'm going to exit out of the load balancer shell. So what else? So we've done the HAProxy load balancer. Now we're going to go to installing the cert-manager from the JetStack Helm Repo. So if I go to the browser and search for, if I go to Helm Hub and search for cert-manager, and I'm going to use the JetStack cert-manager. And they've got the instructions here how to add the repo, Helm repo, add JetStack, and how to install the cert-manager package. So before that, we need to do one thing. We need to install the cert-manager custom resource definitions, CRDs. So this one will deploy a set of custom resource definitions that are required by the cert-manager. So let's do that one first. Copy and paste. So as you can see, it has deployed the custom resource definition, certificates, challenges, cluster issuers, orders. So these are not the core Kubernetes resources. So that's why they are called custom resource definitions. That's done. And one more thing, we are going to install the cert-manager in a namespace called cert-manager. If you happen to have a namespace already with the same name, cert-manager, the requirement is you need to label that namespace. So kubectl label namespace cert-manager with this label. But I assume you don't have that cert-manager namespace created already, so don't worry about that. But if you've got that already, you have to label that namespace with this command. Okay, so now let's go ahead and then add the Helm repo. Copy, paste. Okay, if I do Helm repo list, and you can see the JetStack repo. So now we are good to install the cert-manager. Excuse me. Helm install JetStack cert-manager, copy and paste it, and I'm going to change the name to cert-manager. Okay, so that should be it. And if I do kubectl get namespace, you can see cert-manager. Let's see what has been deployed in that namespace. Kubectl -n cert-manager get all. Okay, so there's a container that's getting created. A couple of cert-managers. I think it's deployment. Yep, cert-manager, whatever it is, CA injector, webhook. Okay, so the container is still getting created. Cert-manager webhook. Okay, cool. I think we are fully up and running with the cert-manager. So that's all it is, cert-manager. Kubectl get custom resource definitions. So these were the custom resource definitions that we installed using the first command here. Okay, so the next step is to deploy the cluster issuer resource. What I've done is, if you go into here, more information on the different types of issuers, you can go in here, and these are the different types of issuers: Acme, CA, self-signed, Vault, and something else. And if you go down here, create a basic Acme issuer. So this is the configuration, but I've got it in my GitHub repository. If you do ls here, I've got the YAML here, cluster issuer.yaml. Let's see what's in there. Okay, so API version, cert-manager, kind is cluster issuer, metadata, it's just a name. Let's encrypt staging, and it's of type Acme, and the server. So there are two types here. The let's encrypt, you've got the staging as well as the production. So for testing, I'm using the staging URL, which means the certificate that it's going to generate are just fake certificates, just for testing purpose. If you want to use it for production, there is a production URL, excuse me, which needs verification and things like that, but I haven't tried that. So this is a quick demo. I'm going to leave it with you to test the production URL. The only requirement is email. So if you just leave it user@example.com, it won't work. It needs a valid email. So for example, I'm going to give my email venkaten@gmail.com. So that's all it is, and we're going to deploy that cluster issuer. kubectl create -f cluster issuer.yaml. Okay, so that's created. And the next step is to create a sample Nginx deployment and expose it. ls Nginx deployment. I've got the Nginx deployment here. It's a very basic, simple Nginx, nothing special about it. Nginx deployment.yaml. As you can see, type deployment, one replica, Nginx, and the image is Nginx, nothing special about it. So let's deploy that. kubectl create -f Nginx deployment.yaml. That's created. kubectl get all. Nginx pod is running. So now let's expose it as a service. kubectl expose deploy Nginx port 80. kubectl get all. Okay, so we've exposed the deployment Nginx as a service of type cluster IP. Bear in mind, the service is of type cluster IP, which means there is no access from external to this service or to this web application. So within the cluster, there is access, but not outside. So normally you would use node port, or if you're using a cloud provider, you'd use service load balancer. So that will create a load balancer for you in the cloud. As we are using bare metal, we can have a load balancer. I've done a video on it using metal LB. For this demo, let's use the default cluster IP. So that's how it usually works. So now we're going to deploy an ingress resource. So this is the important bit, and I'll explain you. I've got the file created here, ingress resource.yaml. Let's take a look at that. Okay, so that's it. Kind ingress, you give it a name. So this bit is important. Annotation. So you're attaching an annotation to the ingress resource. Cert-manager cluster issuer is going to be let's encrypt staging. If you remember the cluster issuer manifest that we deployed, if I edit that file, you can see the name is let's encrypt staging. So it needs to match. Ingress resource.yaml. So we need to add this annotation, otherwise the ingress doesn't know where to get the certificates from, which certificate authority to use. So that's the important bit. Annotations, let's encrypt staging. Okay, and then the spec. So here we are given the option TLS, and for hosts, you can list any number of hosts. So I've added nginx.example.com as the DNS name of the Nginx application. Secret name is again let's encrypt staging, as in the cluster issuer.yaml manifest. Let's encrypt staging, and now comes the rules. So if a request comes in to the Ingress controller for nginx.example.com, the default backend is going to be the Nginx service, and the port is 80. So we have Nginx service. So any request coming to the Ingress controller for nginx.example.com will be routed to this service Nginx running on port 80. So the TLS endpoint is the worker node, the Ingress controller. So the users will access the IP address of the load balancer, and then on port 443 HTTPS. So the connection between the load balancer and the worker node is encrypted using TLS. And once the connection comes into the cluster, the connection between the Ingress controller and the service is on port 80 is plain text. It's not encrypted, so we don't need encryption within the cluster. So the TLS endpoint is on the worker node on the Ingress controller. Okay. Right. We I don't think we've deployed the Ingress controller. Let's do that. kubectl create -f ingress resource.yaml. That's created. And if I do kubectl get ingress, so we have the Ingress resource we just deployed, and it's listening for ports 80 and 443. And if I show you the details of this Ingress resource, you can see the certificate that it has generated for us automatically. kubectl describe ingress resource. So the namespace is default. TLS, you can see here, let's encrypt staging terminates nginx.example.com, and the annotations that we added to the Ingress resource. Okay, so here you can see create certificate, successfully created certificate, let's encrypt staging. Right, and we've got the certificates created. And if I do kubectl get certificates, let's encrypt staging. So we've got the certificate created automatically. Let's see what's in there. kubectl describe certificate, let's encrypt staging. So that's the certificate for the domain nginx.example.com. So that's the DNS name. Issuer, so who is the issuer? Cluster issuer is let's encrypt staging. Reason is a temporary certificate. Message certificate issuance in progress. Temporary certificate issued. Yep, generated a new private key. Generated a temporary self-signed certificate. So these are just fake certificates, just to show you how it works. Okay, so finally, we got to do the DNS update. So for that, I'm going to update my etc host file on my host machine. Sudo vi etc hosts, and I'm going to add the IP address of my load balancer, lxc list. So HAProxy, so that's the IP address of HAProxy load balancer. Paste it in the etc host file and nginx.example.com. So whenever I connect to nginx.example.com, it's going to take me to the load balancer, right? Okay, so now comes the testing bit. So I'm going to go to the web browser and type in https nginx.example.com. Cool, so we are getting a certificate, but it says your connection is not private because my browser doesn't know this certificate authority, because it's just a fake certificate. So that's okay. So this is a self-signed fake certificate, but it shows you that it's working. Okay, so click advanced, proceed to nginx.example.com, and there you go. You've got the Nginx welcome page. And if you click here, if you want to see the certificate details, click on the certificate and you can see issued to nginx.example.com, issued by cert-manager, issued on 11th of May 2019. So that's when I'm recording this video right now, and expires on August 2019. May, June, July, August. Okay, it's for 3 months. And you can see the details if you wish. Validity, not before, not after. So that's 9th of August. Okay. Okay, so that's it. Yep. I don't think I've got anything else to show in this demo. Yeah, I think it should give you a good understanding, a clear picture of how the Let's Encrypt TLS certificate works. So this video, especially this one, I've gone through every single step very quickly. So if you don't understand anything, or if something is not working right for you, please leave me a comment. I'll be more than happy to help you. Right, if you enjoyed this video, please share it with your friends. And if you've got any feedback for me, please let me know. The way that I explain things in YouTube, if you want me to change slightly something or some aspect of my recording, please feel free to comment. And I hope you have subscribed to my channel. If not, you know what to do. And I will see you on my next video. Thanks for your time watching. Bye-bye.